Okay, what if I told you we could fight cancer, not with radiation, not with toxic drugs, but with sound? It sounds like science fiction, right? Well, this is the incredible true story of how a music professor's side project led to a stunning breakthrough in cancer research. And it all comes down to the simple physics of vibration. So, let's meet the man at the heart of our story. His name is Anthony Holland. And get this, he's not a biologist, he's not an oncologist. He's a music professor. He literally conducted orchestras by day and then hunted for a cure for cancer by night. And his whole journey really kicks off with this pretty intriguing admission. So you've got to ask yourself, what drives a music professor into a science lab? Well, it was a shared dream. You see, Holland and his partners in the science world, they were all united by this one powerful belief. There had to be a better, a gentler way to treat cancer, especially for kids. A way without all the devastating side effects of the treatments we have now. They were looking for something that was not just effective, but kind. And their search for that better way led them to a really fundamental principle of physics. In fact, it's one you've almost certainly seen in action, even if you didn't know the name for it. It's called resonance, and believe me, it is the key to this entire story. Okay, so what is resonance? Well, the crucial thing to get is this. Everything, and I mean everything, has a natural frequency. Think of it like a specific musical note that it just wants to vibrate at. Now, if you pump energy into that object at that exact frequency, the vibrations just get stronger and stronger and stronger until the object literally can't handle it anymore and it just breaks apart. That is its resonant frequency. All right, let's start small. You take two identical tuning forks. You strike one, and what happens? The second one, just sitting there nearby, starts to hum all on its own without anything touching it. It's not magic, right? It's just that the sound waves from the first fork are transferring energy to the second one at its perfect resonant frequency, making it vibrate in sympathy. Okay, now let's amplify that effect of it. You've all seen the classic example, right? The opera singer who finds the exact right pitch for crystal glass, holds that note, and pow! The energy builds and builds inside the glass until its structure just fails and it shatters into a million pieces. That right there is resonance in destructive action. And look, resonance isn't just for small things like glasses. In 1940, a steady wind, and I'm not talking about a hurricane here, just a constant breeze, it just happened to match the resonant frequency of the Tacoma Narrows Bridge. And those vibrations just grew and grew uncontrollably until that massive steel and concrete structure literally tore itself apart. It's wild. So, this brings us right to the core question of Holland's research, the big what if. If resonance can destroy something as massive as a bridge and as delicate as a wine glass, could you scale it down? Like, way down? Could you find the specific, unique resonant frequency of a cancer cell and shatter it while leaving all the healthy cells around it completely untouched? With that powerful question hanging in the air, the team began the next phase of their journey. And let me tell you, this was not a quick discovery. We're talking about a painstaking, methodical, 15-month-long search for the precise combination of frequencies, that magic note, if you will, that could act as a kill switch for living cells. Their path was actually pretty clear. First, you need a theory, right? They found one in the work of scientist Mei-Wan Ho, who suggested that living cells actually behave a lot like liquid crystals, meaning they can be affected by electronic signals. Okay, step 2, find the right tool. They found a device invented by a Dr. James Baer that was designed for this exact kind of thing. And finally, step 3, begin the long, hard search. Now, this device was special, and for two really important reasons. First, instead of a normal metal antenna, it used a glass sphere filled with electrified gas, basically a plasma antenna. This turned out to be perfect for working with biological stuff. But here's the really crucial part. Its signal pulsed. It went on and off, on and off. Why does that matter? Because it avoids generating heat. Heat would just cook everything indiscriminately. They were aiming for targeted, non-thermal destruction. No heat, just vibration. I mean, can you just imagine the patience this required? For 15 solid months, they sat at a microscope, testing frequencies one by one. 100 hertz, nope. 101 hertz, nothing. 102, you get the idea. They tested thousands upon thousands of these individual frequencies day after day, until finally, they found it. They stumbled upon the secret. And here it is, the big breakthrough moment.
The answer wasn't one frequency. It was two. A low one and a high one played at the same time. And the magic ratio between them? The high frequency had to be exactly 11 times the low one. Now, for Anthony Holland, the music professor, this was like a lightning bolt. It was a concept he knew well, the 11th harmonic. That musical principle, that was the key that unlocked the whole thing.
So, with the secret of the 11th harmonic unlocked, the team could finally move on from simple microorganisms to the ultimate target. This was it. This was the moment they had been working towards for all those months, applying their brand new technology directly to cancer cells. And their first success was just wow. It was stunningly precise. They aimed their frequencies at this little microorganism called blepharisma and just watched it disintegrate. It just fell apart right there under the microscope. But here's the amazing part. A totally different kind of organism swimming right next to it was left completely unharmed. This was the proof of concept they needed. It proved you could target one specific thing without any collateral damage. So after tons and tons of experiments, they started to narrow down the kill zone. They discovered that cancer cells specifically were vulnerable to frequencies in a particular range, between 100,000 and 300,000 hertz. Now they had a target to aim for. They were zeroing in. Okay, so how effective was it really? Well, take a look at these results for leukemia cells in their lab experiments. On average, the treatment was killing between 25 and 42% of the cancer cells, but at its peak, it reached a 60% kill rate. Now, to put that in perspective for you, a scientist told Holland that if a pharmaceutical company came up with a new drug that had those kinds of numbers, it would be considered an absolute home run. But wait, it gets even better than that. The treatment didn't just kill the cancer cells. It also crippled the ones that survived. What they found was that the frequencies slowed down the growth rate of the remaining cancer cells by as much as 65%. So it was this incredibly powerful one-two punch. And this success wasn't just limited to leukemia either. They saw incredible effects on other really tough targets. They shattered ovarian cancer cells. They broke apart pancreatic cancer tumors. And then, maybe most remarkably of all, they found that the frequencies actually eliminated antibiotic resistance in the deadly superbug MRSA. I mean, the potential applications here are just huge. Look, these results are so much more than just numbers in a lab. What they really represent is a vision for a completely new future of cancer treatment, one that's painless, non-toxic, and, you know what, maybe even beautiful. And this is the dream that drove all of this research in the first place. Just try to imagine it. A treatment room that doesn't feel like a hospital at all. It's a place where kids can just be kids, playing, drawing, making friends, all while these beautiful blue and pink plasma lights overhead are silently and painlessly delivering the healing frequencies. This quote really just captures the ultimate goal perfectly. It's not about waging a war on the body. It's about a precise, targeted action, shattering their cancer, painlessly and non-toxically, one single cell at a time. I mean, that is a profound shift in how we even think about healing. And that leaves us with one final thought to chew on. This entire incredible story happened because someone from the world of music dared to step into the world of biology. And it really makes you wonder, doesn't it? What other incredible discoveries are just sitting there, waiting to be found, hidden in those unexplored spaces between different fields, between art and science, between music and medicine?